The biggest challenge for today's society is realizing a sustainable way of life. Gas turbines are a major backbone of global energy production. Making these gas turbines more sustainable is our joint mission, using the capability of additive manufacturing to make innovation possible. This is our story, doing it the AM way. This is a turbine guide vane. It is conventionally cast from a nickel-based superalloy and then built into the stator ring of stage 1 and 2 of a gas turbine, up to 100 vanes for both stages. Placed inside a turbine, they have to withstand temperatures of over 1,800 degrees Celsius and are designed for extreme conditions.
It's therefore vital to have a good cooling structure within the components. And as a designer, it's a beautiful thing that we can be a part to both design this and affect it.
You are not limited due to materials or geometry. You're quite free and you can design an ideal vane. So from the shape of the vane, but also to optimize the cooling channels so that you can reduce cooling air and save fuel at the end. This is why we have this positive impact on our decarbonization strategy.
And the saved cooling air could be used for the efficiency improvement or could be used for the lifetime extension of the components.
We have proven that we have more efficient components like the vanes with less cooling, but we also have developed the burner to be able to burn 100% hydrogen.
The AM vanes are now for more than 2 years in operation in our gas turbine in Hattorf, and they are performing great. Afterwards, we could see that the fuel consumption was reduced by more than 1.6%, while simultaneously the electrical output was increased by more than 1 megawatt.
More than 100 components are already implemented for the commercial operation, and we did reach more than 1.5 million operating hours. We not only want to be the part of the decarbonization journey, we would like to be on the lead of it.
The market proof of the Siemens Energy applications show that AM parts can be validated and produced in series for critical applications, making AM the new normal for innovative and efficient gas turbines.
I will not stop to explore our new technologies like additive manufacturing until we have achieved that we have a high efficiency gas turbine burning green fuels.